what we did is research on when you burn wood for fuel to cook your food,
Hi, my name is Jared Maggio. I'm a PhD student in environmental engineering at Michigan Tech, and welcome to Kitchen 2.0. This is a design project funded by the Environmental Protection Agency to look at how small design changes in the ventilation can reduce air pollution for the developing world. And so we're taking a more holistic approach to this kind of problem rather than just introducing one solution of like an improved stove. We can look at how ventilation can actually affect and save people's lives. So come on in. So what we were able to do is model these homes and look at the air quality going through. So we also tried to do it computationally. So using computational fluid dynamics, we're able to quickly iterate these design processes and seeing how that affects the indoor air quality. So in this situation, we have a cross ventilation. So the stove is over here, and you've got a window over here and a window up in there. And because of laminar flow, you're able to decrease the amount of air pollution, and it's ventilated outside of the home. Alternatively, on this side of the house, this is supposed to model a more enclosed environment. And so here you have the highest concentration, right around the stove. So you don't have a lot of airflow. So the pollutants kind of stick around, and this is where the cook is, and they're exposed to that most amount of air pollution, and it causes about 4 million deaths every year.
My name is Molly. I'm a senior in the environmental engineering department here at Michigan Tech. So this is a graph of some of the results that we found with measuring the amount of particulate matter that's smaller than 2.5 micrometers inside our test kitchen. So with an all-closed ventilation situation, a traditional 3-stone stove, we're getting over 160 micrograms per meter cubed over a 24-hour period. That is 42% better when we put in a ventilation situation with the same type of stove. We have some improved stoves here as well, and we found that when we have the improved stove and the ventilation, we actually get 83% better results. And just to compare to some cities around the world that are known for some bad air pollution, we have Beijing, which we see on the news, people wearing masks when they're walking around. That's actually about on par with a ventilated situation when you're cooking in a home with biomass. We also think in the US, we think of Los Angeles as having poor air quality. That's even a lot better than any of these cook stove situations. And we'll be presenting this in Washington, D.C. At the National EPA competition, so we also put Washington, D.C. as a reference point on our poster.
Hi, I'm Tanvir. I'm a PhD student in the Environmental Engineering Department here in Michigan Tech. I was just coming out from the building and I saw this little structure here, and I was aware of this project, the indoor air quality measurement from the biomass fuel burning. I did my undergrad research on the air quality studies in my country, Bangladesh, and I know this is a serious problem in developing countries. Like Jared is working in Tanzania, so I came here and I talked to Jared, and I found this research is really interesting because they are trying to solve the problem, the indoor air quality problem, by better ventilation, and they are also measuring the air quality like the PM 2.5 and carbon monoxide level. So they can actually compare what type of ventilation condition is useful to really reduce the air quality in the housing in developing countries. Okay, so this is something you can always find in a typical low-income areas where people have no access to natural gas or electricity. So they always burn the biomass fuel, and you will find that they have this kind of stove at the corner of the room, and you can see those black coloring here. But actually, if you go to the real house, you will see those black particles, soot. Those are all over the walls. So that actually tells you, okay, the extent of air pollution. You don't have to really go and measure. That color actually tells you the real story. So you can also see that all the things here in the utensils are black because of the black carbon emission, which is a result of incomplete combustion from the fuel. So there is another scope to improve the fuel efficiency to reduce the black carbon emission also.
What we have going on here is a three-part project. What this is a test kitchen that we built that we use to test a bunch of different ventilation and cooking scenarios to try to improve indoor air quality. My contribution to this project is I made a computational fluid dynamics model, which based on the test results that we got from the testing, we can put those into the model and try to predict what different ventilation situations might do in the real world. This is the results of one of the computational fluid dynamics simulations that we did. What it shows, it's a two-dimensional slice there. It shows what the indoor air quality is like according to our model. This is one of the situations that we ran. We had this stove here. We took all the test data and basically used it to make this model. This model we can hopefully use to predict how different stoves will act in real-world situations.
Sure. I'm a third-year anthropology and biology student. My contribution was looking at a whole bunch of different surveys that we sent out to Peace Corps International students. So we collected a whole bunch of data on how people were cooking. We wanted to know what kind of fuel source they were using because that can change the different pollutants. Social behavior around cooking because that will also affect, and just so we can better design for them and humans all across the world.